Hello all. Good evening. We'll wait for a couple of more minutes for more people to join, and then we'll start.
Good evening, ma'am.
Good evening. Yeah. All right. Let's start the session now. So we'll start first with like many of you have issues in like how to create the student portfolio for extra activity. For those who are in qualifier, as you don't have the student email ID, what we are suggesting is that you create some portfolio, any sample you take, and you just you can create the portfolio from there. So I will demonstrate like how you can do it here in a couple of minutes. So for the people who does not have student email ID, you can follow that. Okay. And to those who already have the student email ID, those who are in foundation now, you can go ahead, proceed with the same that was mentioned in the on the portal. Okay, now I will present my screen. So hope this is visible to you. So what you have to do is, you just go to Google site, close it, go to Google site and go to sign in. So since you don't have the student email ID, what you can do is you sign in using your personal email ID that you have used while registering for the IITM course, right? So I have already logged in using my personal ID here. So I will go there. Now you can see I don't see the option of student portfolio, right? I don't have this option. So what we will do is we'll go to the first portfolios here that is given. So I click here. Now you can change, you use the same format that is given here, and remaining theme you can change definitely. So I will just change this. So I will type my name. So you can accordingly modify. You can put your name, you can put your role, you can write as a student. I'm writing instructor. Okay. So you can modify this, and theme you can change accordingly, whatever you like. Now you can go to on the left hand side, or sorry, on the right hand side, you see the pages right here. Now you go to pages, you click on about. So I changed the name of about to classes. So I will write this as classes. Then I go to the sub page. I make a sub page over here. So I will add a sub page, and I will name it as statistic for data science 1. And done. So I can also go to the setting and just change this as a side view, right? So you can see you will get, now you have classes, under the classes, now you have statistics for data science 1. And now you can perform the same activity that has been given to you. So on the portal, you see one video. So now follow the same procedure that is given there. Hope this is clear to all of you. Anyone?
Yes, ma'am.
Okay. All right. So please follow this step for all those people who doesn't have the student email ID yet. You can use this process and you can submit your extra activity. The deadline has been extended to 24th, so you still have time to do it. So please proceed with the assignment. Now we'll go to solve with this.
Sorry, ma'am.
Yes, please go ahead.
Actually, sorry, ma'am. I just joined the class.
Okay, no worries. So I was not doing anything. I just demonstrated like how the people who does not have the student email ID, how they can go ahead and create their student portfolio.
Okay. So you
Yeah.
already explained that, ma'am?
Yeah, I already explained it.
Okay. So I will see the recording, ma'am. Okay.
Yeah, please see the recording.
Okay. Thank you. But summary is that we can just use our own IDs and do the best, or what is that summary, ma'am?
The summary is, hold on. So the summary is that I have, if you go to Google site, since you don't have the student email ID, you can create your own portfolio. So we have given one sample example there. You can choose that. And on that portfolio, I have mentioned what all changes you will have to make. And then you are good to go ahead with whatever is given in the video earlier.
Where did you give that sample portfolio, ma'am?
Sample portfolio, okay. Let me share it again. Okay. So okay, you have to go to Google site. Then you sign in using your personal email ID. This I have used. So this is my personal email ID. So I'm not getting the option of student portfolio. See, since I'm using This one I'm using the study.iitm domain. So I'm getting the option for student portfolio. But if I go ahead and I want to create the portfolio using using the personal ID, I don't get the option to create using student portfolio. So what we did is you can take this first option of the portfolio and you can modify there. You can modify here and use the same process, whatever we did earlier. So I've already explained what all changes you have to make. Maybe you
Okay.
can go ahead and look at that.
Okay, ma'am. Thank you. I'll ask in the next class any doubts.
Yeah, sure. So now let's start our Solve with a session. All right. We'll do this today's Solve with a session for week 8. So this is a peer deck slide. So please go to joinpd.com and use the code IWNGZ. So go to joinpd.com and use the code that is given here on the top right hand side corner of the screen, which is IWNGZ. Okay, all of you join the class. Can you confirm if you have joined,
Yes,
if you have used the code and joined this class?
Yes, ma'am.
Okay. All right. Let's move further then. So I'm sure now you will be quite familiar with what exactly has to be done here. So you will have the option to write your answers. You will be shown one question on the screen and you'll have to write the answer for that question. And you'll be given around 2 to 3 minutes, depending on the type of question it has. And you have to write your answer and later we will see the solution for that. Okay. So here we have the first question. The first question says, this is a prelude to first question. So it's like the sub part of what you're going to see in the first one. So here the question says, an urn contains 5 blue balls and 8 red balls. Okay. And you choose one ball at random from the urn. Now, what is the probability that the ball that you draw is red in color? Set the timer here. Maybe 1 minute. It's quite easy.
Ma'am, how to submit the response? Ma'am.
Oh, sorry, I was on mute. I was asking, are you using the mobile or the laptop?
Laptop, ma'am.
Laptop. You should see an option on the right hand side.
Now, actually, it says that your teacher has logged the responses for this slide.
Yeah, I did. I can
Earlier,
unlock
I
it.
didn't have an option to submit. That's okay, ma'am. Right
Can you
now.
check now? I have started again for a minute.
Still, I don't see a response option to submit, ma'am. I see, I entered the answer, but I'm not getting an answer.
That is already recorded. You don't, there is no option to submit.
Oh, okay. I just have to enter, and when you log the session, and it'll whatever I have entered will be taken. Okay, thank you.
Yes, yes.
Thinking, there are few doubts. Can we shoot the doubts also in the chat box or somewhere, ma'am?
Doubts in the chat?
Yeah.
No, I didn't understand.
No, there are few doubts. Do you want us to post it into the chat box or something, or you go take?
Is this regarding this question?
No, not this question. Just
Then you can post it in the chat.
okay, ma'am. Thank you.
Okay. All right, then I will just show the responses. Okay. You see, many people have answered near 0.6. Okay. That seems to be right answer. Let's see. So here, see here, we already know that in a non, you have 5 balls and 5 blue ball and 8 red ball. And if you choose one ball at random, then probability of that ball being red will be just number of red ball in the on divided by total number of balls in the on, right? So that should be 8 divided by 8 plus 5, which is 13. So 8 divided by 13 would be 0.62. So most of you have answered right. I see 0.5 as setting 1 or 2 answer. I'm not sure why you wrote 0.5. So if someone of you can answer me, like, why did you think 0.5 is the right answer? That would be great. No one? Okay. Any doubt in this question?
No, man.
Okay. Let's move further. So now what we are saying is, it's the same situation. You have an on has 5 blue ball and 8 red balls. Now, instead of choosing one ball, you are choosing 2 balls. You're drawing 2 balls from the on without replacement. Okay. So what is the probability that the first ball that you select is red and the second ball that you select is blue? The screen for 1 minute. Okay. Do you need more time to solve this, or I see how many people? 6 people only. I will start this for 1 more minute.
Ma'am, for me, it is still saying that your teacher has logged out.
What?
Yeah. No, ma'am. Actually, no, I was not able to enter before. Now I'm entering here.
Yeah, now you should be able to enter.
Yeah, sure.
Maybe I should have given 3 minutes for this.
No, done, ma'am, actually.
Okay.
It is done. There was a problem. That's all. Thank you.
Sure. Okay, I see 14 responses. Please do not write the answer over here in the chat. You can write your answer in the peer deck. Okay. So I have closed the responses for now, but from now on, I will give more time to write your answer. So here, what do you have to do? Like before, we were drawing just one ball. Now, what we are saying is we are drawing 2 balls, and they have been drawn without replacement. So when we say without replacement, it means you draw one ball and you don't put it back in the urn, and then you draw like without putting it back in the urn, you draw another ball. So before, let's say when the total number of ball was 13, once you draw one ball from there, now you will have only 12 balls left in the urn, right? So here we are saying what is the probability that the first ball is red and the second ball is blue, right? So when you choose when you draw one ball from the urn, then first of all, what is the probability that ball will be red? That we have already found. That was 8/13. And now we have to find that what is the probability that the second ball is blue. So now we know that in the urn you have total number of blue balls as 5. But now since we are not putting the red ball that we had found drawn earlier, so now we have the number of balls left is 12, right? So the answer should be 8/13 times 5/12. So let me see the responses. Okay, I see a lot of different responses over here, but 2 of them are quite close. All right, let's see. So the correct answer is 0.26, right? So we define the first event. Let's define the event R as first ball is red and define the event B as second ball is blue. And basically what we have to find is probability of occurrence of R and B, right? And we know that this joint distribution is given as product of marginal times conditional. So marginal probability of red is just 8/13. And since red has already occurred, what is the probability of observing the blue ball? So that will be 5/12. And hence the answer is 8/13 times 5/12, which gives us 0.26. So 0.26 is the right answer.
Ma'am,
Yes.
in this question, we choose 13C2.
13C2. Yes.
Then answer is 0.5 something.
No, I mean that would be that is not taking into account that your ball is red or your ball is blue, right? I mean you're just saying that out of 13 balls you're choosing 2 balls, right?
Then 8C1 multiplied by 5C1 divide 13C2. It is correct?
8C1,
8C1 multiplied by 5C1 divide by 13C2.
13C2. Yeah, this should be right.
But
So
answer
what you will
is
get into
not
8 into 5 divided by 13 into
13C2. Factorial 30 minus
13C2.
12.
Yeah, that's right. But okay, now what is happening is why you don't have to you will have to divide it by 2, because when you are just saying that you're choosing 2 balls, there either you choose the first ball as red or you choose the second ball as red. That doesn't matter, because there we're just saying they're choosing 2 balls. But here in the question, what we're asking is we are specifically saying that the first ball should be red and the second should be blue, right? So you need to divide it by 2, because you have what you have calculated.
But ma'am, it is a simple 13C2 selection of 2 balls.
Here order matters. No, here order matters.
So ma'am, how to divide by 13 and 12?
No.
Just can.
What you have to do is, see, you are choosing what you have written is fine, okay? You have said 8 choose 1 times 5 choose 1 divided by 13 choose 2. Fine.
13C2.
But this is only, but what it is giving is, it is giving you the probability that one ball is red and other ball is blue. So it can either be the pair blue red or red blue, right?
No.
Yes.
But
Because-
select.
Yes, selection,
Here,
right?
yeah, here in this question, it clearly says that first ball is red.
Yeah.
So it is not saying that what is the probability that when you pick the 2 balls, one ball will be red and other ball will be blue. What they said was first ball red, second ball blue.
Ma'am, kindly so question.
Yeah, I will show the question. Here order matters to you. The order in which you are drawing the ball matters. So what you are finding is that one ball is blue, other ball is red. But what you have to find is that specifically the first ball is red and the second ball is blue. And since what you found for that, the 2 cases are possible, so now you need to divide it by 2.
Okay, got it, ma'am. In this case, 8C1 divided by 13C1 and multiplied by 5C1 divided by 12C1.
Not 13C1.
Exactly 30. First of all, we select first ball is red. Then 8C1
times 5C1.
and first ball selection is confirm is a red ball. Then out of total balls we select one ball divided by 13C1, because he question says that the first ball is red. Then we go to the blue ball 5C1 and select the remaining 13C1. We got one ball, then remaining 12 ball is remains, then 12C1.
Yes, correct.
Okay.
Yeah. Okay.
Okay, ma'am.
Hope it is clear to all of you. All right. Let's move to the next question. The question says, student writes an exam with 2 sections. The probability of passing section 1 is 0.8 and the probability of passing section 2 is 0.9. The events of passing section 1 and 2 are independent. Then what is the probability that student passes both the sections? So let's say you were writing an exam and in the exam, the paper has 2 sections. Okay. And the probability that any student passes the first section is 0.8. And the probability that any student passes section 2 is 0.9. And what we are saying is event of passing section 1 and 2 are independent. So it doesn't passing in one section is not dependent on the passing for another section. So what you have to find the probability that what is the probability that student passes both the sections. So I have set the timer for 3 minutes. So let's think about it and give your answers. You can submit the answer on, so you have to go to Peer Deck. So go to jointd.com and use the code that you see on the top right hand side corner of the screen, which is JUU IUUNGZ. And there you will see this question, and near that question you can write your answer. All right. I see 21 responses already here. So let's see. Okay. Here we have 3 different answers. 0.72 and 0.99, and there is something in the middle also.
Ma'am, can we see how many people have responded 0.72? How many like that? Can we see it on the screen there?
No, it is not possible to see the numbers.
Okay, okay.
Yeah. See.
Because often we can make out which is the correct answer probably by seeing the number of answers going.
Oh yeah, we can see. We can.
Yeah, no. In the other graph, does it give the count?
In the other graph, it
Here,
doesn't give the
here
count.
if it gives, we'll know we can actually make out to a great extent.
Yeah, but yeah, from here we can see. So a lot of you have given 0.72 as the answer, if I can see. And 2-3 of you have given 0.99, 0.85, so on. Okay, so we had to find what is the probability that student passes both the section, right? So it is, and so let's say you define the event 1 as the event that a student passes section 1, and let's say you define another event B as student passes section 2, and what you have to find is you have to find the probability of A and B, right? And since it is given to you in the question that A and B are independent, right? So if A and B are independent, we know that probability of A intersection B should be probability of A times probability of B. So that probability was already given to us. Probability that any student passes section 1 was 0.8, and probability that any student passes section 2 as 0.9. So that turns out to be 0.72. Okay. So somebody had asked in the chat, how do we find in case it is not given to us that what is probability of that event A and B are not, like these two events are not independent. So if the events are not independent, then in that case, it is difficult to find using the information that is provided. Maybe in that case, you need more information to work on that.
Oh, okay, ma'am. And any question regarding that which we can see? If the events are dependent, what more information do we require like that?
Ma'am, independent.
Somebody was saying something.
Yes, independent case. We use Bayes theorem. Like
We
this
use
type of questions.
Bayes theorem for this kind of question. No, I didn't fully understand. Can you repeat again?
If case is dependent, then what we use
If they are
in this
dependent,
question?
yeah, you need more information. Let's see. I will look at some question and I'll give you.
Okay, ma'am.
Yeah.
Hello,
Yes.
ma'am. There is a similar question in activity 8.7, but multiplying it giving a wrong answer.
8.7 activity.
Yes, ma'am. Second question.
Okay, you can keep it. You can just
You can
put
post
it in
your
the
question
chat.
in the chat box, and ma'am
Yeah,
will probably take up all those things at the end. I have already posted one.
yeah. So let's post it on the chat, and once the slides are done, we can go ahead and look at that question. Okay.
Yeah, I have posted it in chat. So
Okay. Sure. Okay, also see one question from Vedika. How to peer review of extra activity 1? So I think the deadline has not been passed yet. So once the deadline is over, you will be assigned randomly some 3 to 10 people, and you can go ahead and check, review the activities of your peers. And there is some rubric that is provided to you. So using that rubric, you have to provide marks to students. Samadhan, my peer text is not working. It shows site can't be reached as I text. So Samadhan, you go to joinpd.com and you use this code IWNGZ. Okay. How to do extra activity? How to do extra activity? It's already one sample example has been given to you on the portal. So please check that. You have to do something in Google Sheet. So please work on that. And I think the first two activities are not really difficult. It's quite simple what you have studied so far. So please go through it once.
Ma'am, just one question about this question, ma'am.
Hmm.
So here it says among all the females, 9% are left-handed. So 9% are left-handed means 9% of the 45% females or 9% of the total. That.
Okay, you already looking at the question. Okay, okay.
Oh,
Um, Okay, so what this question says is you have in the population, 45% are female, 55% are male. Okay, now among all the females, we are saying 9% are left-handed. So all the females that you have in the population, from there you have 9% female as left-handed. And all the males that you have in the population, from there you have 11% people as left-handed. Now, when you randomly pick one person from the population, what is the probability that the person is not left-handed? So many of you would have already guessed like how to find this. Let's give this some time and we'll discuss the solution later.
so ma'am, actually just ma'am, as an
Yeah.
example, if I take 100 is the total population, 45% of the are females. So
Okay.
that means 45 females are there.
Yes.
Now, among all the females, 9% are left-handed. That means 9% of these 45 people are
Left-handed.
left-handed, right, ma'am?
Yes. Yes.
Yeah, then we are actually getting fraction numbers. Okay, fine. Let me proceed, ma'am.
Yeah. Okay.
Ma'am, can you give just 1 more minute? I was just writing my answer.
Sure.
Just 30 seconds more.
Ma'am, please give 30 seconds more.
30 seconds more. Okay. I'll give 1 more minute. All right, let's see what you have answered. Still, I see only 16 people have responded. Okay. So 0.899, 0.899. Oh, it like the answer varies a lot. So how do we proceed with this?
Ma'am, we can consider that the total number of students are 100 and then proceed.
Okay.
Then we can take the number of students who are not left-handed and find the probability.
All right. And what did you get as the answer?
0.899.
2.898. Okay. See, here we have to do nothing but just use the total law of total probability, right? So what is being given here is you have a population and you are dividing your population in male and female. Okay. And you know they are mutually exclusive and exhaustive. Correct? And because 45% we are saying are male, 55% we are saying are female. Now, among the female, we are saying 9% are left-handed, and among the male, we are saying 11% are left-handed. So we have to find another event, E, where we are saying the person is left-handed. So if you have to identify the probability that the person is left-handed, either that person can come from the female or the person can come from male, right? So this is nothing but the setup for the law of total probability. So if you have to find what is the probability that the person is left-handed, then it is just probability that person is left-handed given it is female times the probability of female plus probability that person is left-handed given it's male times probability of male. And that should give you the answer. Sorry, that should give you the probability that person is left-handed. But you have to find the probability that the person is not left-handed. So you just have to subtract it by 1. Right? So that is what we are doing here. We have defined different events. So let's define the event M as selected person is male. Let's define the event F as selected person is female. Let's define the event L as selected person is left-handed, right? To us, probability of male is given to us. Probability of L time given M is given to us. Probability of F is given to us. Probability of L given F is given to us. And since we have to find the probability that person is not left-handed, we just have to do 1 minus the probability the person is left-handed, right? So that is what we are using, and we are using law of total probability, and we get the answer as 0.899.
Ma'am, actually, yeah. 1 second.
Yeah.
So, 0.899. My answer was
Ma'am, can we solve this Bayes theorem?
Okay. You want me to solve this question?
I solve it.
No,
From-
you want me to solve this question again? What did you say? I didn't understand.
Actually, he
Yes.
told that this question can also be
Can
solved by
we?
Bayes theorem.
Yes.
See,
Can be solved using Bayes theorem.
no,
Yes, because I also solve this Bayes theorem.
Okay, you're confusing it. Why? Because in Bayes theorem is nothing but it's like a conditional probability, right? I mean, there you find the conditional probability, but here you are finding probability of an event. I mean, and that event is not conditional event.
What, ma'am? I solved this Bayes theorem, but it is answer given right answer is
How did you find?
0.89.
What did you do? Can you tell me?
In Bayes theorem, we use conditional probability that one occurred and another is occurring. Like this, then 45% probability of 45% and 55% is two case.
Okay.
And 45% is female multiplied by and 0.91% probability of females plus it's going on a male like 0.55 into 89 0.89
Okay.
and add them.
Yeah, that is what we have done. That is not Bayes theorem.
it's total probability.
That is law of total probability, what you are saying.
Oh, and the opposite of this total probability like Bayes theorem, eh?
Not opposite. I mean, okay, I'm coming to the Bayes theorem, then maybe it would be more clear. So,
Yes, ma'am. I have some confusion in this.
okay, so first of all, anybody has any doubt in this question? Okay, let's move to the next part of this. Okay, so it's the same setup. Now, what we are here, we are not finding what is the probability that the person is left-handed. Here, what we are saying is, if the person is left-handed, I mean, if you selected one person randomly from the population, and you found out that person is left-handed. So now, what is the probability that that person is a male? I will give some time for this question.
The person is.
Ma'am, I have a doubt. In last question.
Let's do this first, then I'll go back to the last question.
Ma'am, am I audible?
30 seconds, ma'am.
Yes.
Hello.
I see 15 responses only. Do you want more time for this or?
Yes, ma'am. Some more time.
Okay. Let's put 3 more minutes. Okay. I think, okay, let's see. Still 15 people. How? Let's see the responses. Okay. Again, the responses are like very diverse. All right. So here what you have to do, is if the person is left-handed, then what is the probability that the person is a male? So we have already defined all the events in the previous question. And we have to do what is the probability that a probability of M given L, right? So this is a condition probability. Now M given L is going to be probability of M intersection L divided by probability of L. Probability of L you have already found out in the previous question. And probability of M intersection L is nothing but probability of L given M times probability of M, right? And that should give you the answer. Am I audible?
You're audible, ma'am.
Okay, okay. So here you just have to find the conditional probability that M given L. And this probability of L we have already found out in the previous question. which had come out as 0.101. So this is nothing but probability of M times, so in the numerator, you will have M intersection L, and this M intersection L is nothing but probability of L given M times probability of M, right? And all this information is already known to you from the question. So the answer comes out to be 0.599.
Ma'am, actually, 1 second, ma'am. My answer was 0.599 only. I got the answer, but I am not able to understand this approach, ma'am. What I am doing is actually I'm just assuming that 100 people, and so within that 100 people, how many males are there? How many left-handed males are there, which is 6.05? How many left-handed females are there, which is 4.05? So total left-handeds are 10.1. So the number of male left-handed people are 6.01 by total left-handed people are 10.1. That's how I obtained the answer, which I got 0.59. But so getting answer is not a problem. I got the answer, but I'm unable to understand this approach, ma'am. Like the probability of M, I mean, whatever you just shown and shared, right?
Yeah.
Earlier formula.
Let me share my screen. I will maybe write it and tell you how it's happening.
Yeah. So even for the first question, earlier question also, I got the answer, but the point is, I am not able to put them in this form.
Okay. So see, this is what we had seen in the last class. So what we had said is, let's say we have the setting as the events F1, F2 up to Fk are event F1, F2, F1, F2 up to Fk are mutually exclusive and they're also exhaustive. So basically these events are consisting of all the they are making the whole population, and all these events are disjoint from each other. Okay. Now let's say some event has occurred. So some event E has occurred. Okay.
Yeah.
So in this case, in our example, what was the population? The population was, so we had only the population consists of only male and female, right? So we define the, just give me a minute. Yeah. So we had male, let's denote it as M, and female. And male, this is like 55%. And female, we are saying it's 45%. Right? And they're also mutually exclusive and they're exhaustive. Now we are saying one event has occurred. Let's say this is my whole population. Okay. So let's say some event E has occurred. So in our case, the event E is the person being left-handed.
Yeah.
Right? Let's denote it as L.
Yeah.
Now, if you have to find the probability that person is a left-handed, then this left-handed person can either come from the population male or it can come from the population female.
Correct.
So you have a condition on that. So it is more like, so probability of L, if you look at this, this graph, so you can write it separately as, so you can write L as L intersection with M union L intersection with F.
Correct.
Right? And these two events, since M and F are mutually exclusive, this L intersection M, L intersection F will also be mutually exclusive. So in that case, probability of L, I can write it as probability of L intersection with M plus probability of L intersection with F. right? Now, you have seen it that the joint probability can also be written as marginal times conditional, right? So I can also write L intersection M as what? This can be written as probability that L given M times probability of M, right? And L intersection F can be written as probability that L given F times probability of F. Now, in the question, if you look at it, we are given probability of M to be 0.55.
Okay.
We are given probability of F to be 0.45. We are given probability of L given M to be, I guess, 0.11. And probability of L given F to be 0.09, right? This is what is given.
Yes, ma'am.
Now you just substitute it here. Now you have to find what is the probability that the person is left-handed. So L times given M is 0.11 times 0.55 plus this is 0.45 times 0.09, right?
Yeah.
And this will give you the probability that the selected person is a left-handed. Now this is what we're saying is you have to find the probability of this event L, okay? But in case what we are saying is now from this population, I am selecting one person. I'm selecting one person. Now you have to find what is the probability that this selected person is a male, right? So this is probability of male, and what you have observed? You have observed that the person you selected is also left-handed. So this information is given to you. I mean, it is given to you that the person you selected is a male. It is given to you that the person you have selected is left-handed. Now, what you have to find is what is the probability that that person is a male. So this is nothing but a conditional probability setting. Probability of M given L, right? And this is what? This is going to be probability of M intersection L divided by probability of L, right? And probability of L we already found out. It's this. So it can just go in the denominator, and in the numerator, M intersection L is what? This is just probability of L given M times probability of M divided by, you have probability of L, right? So this will give you the probability that the selected person, the person chosen, the person which you have selected randomly from the population is a male, given that we had observed the person is left-handed, right?
Ma'am.
Yeah.
Ma'am, I have a doubt. Probability of left-handed ma'am is 11% of the given male, na?
Sorry.
Ma'am, there is a you written probability of left-handed is given that it's a male. It must be 11% of the given male, na?
No, I'm not.
Yes.
Not able to understand.
I'm saying that the total number of males, 11% of males are left-handed. That is what given by PL by.
Yeah, 11% of male are left-handed. That's true.
But you written only 11%.
No, just look at the question. Wait. The question says
But it must be 11% of the.
among all the females, 9% are left-handed. So,
it should be 9% of 0.45.
No.
Yes, ma'am.
No, that is not the case. Let it go.
No, 0.45 is also the probability of getting a female. It won't be 0.49% of 0.45. That's not the number of females. That's why you're not.
Yes.
That's why you won't do 11% of that 0.45.
Yeah, or what you're saying is, can you repeat? I couldn't hear.
Ma'am, probability of left-handed man, given that that's a male, it must be 11% of the given male, na? It's like 0.11 into 0.55, na?
No. What is given to you is like, given that you have all the male or the female among, I mean, what is the probability? Like, what proportion of like, given that you have seen it's male, what is the probability that the person is left-handed?
Actually, it's the other way around, ma'am. You picked a person, and that person happens to be left-handed. Then, what is the probability that that person is male? That is the question.
Yeah, that is the question. That is fine.
He
In
asked
a question, we use a total probability theorem, na? So we have to calculate 11% of the male. That's 5. So we need to calculate 11% of the 55 males. That is the probability of left-handed male.
Yes.
Yeah, that is what you're doing here, right? 0.11 times 0.55.
Yes, this is right. No problem.
That's a total, ma'am. That's probability of left-handed and probability of male. But there is a probability of left-handed given that that's a male. It must be 11% of the selected male.
Yeah,
No,
see,
it is
if you
already
look at
given.
P of L intersection M, what does it mean? It means the person is also a male and left-handed. So this is what exactly you're finding. What you're saying is exactly the same thing you're finding, no?
Yes.
You're finding the person is a male and a left-handed also. So that number is nothing but 0.11
My
times
answer is
0.55. Right?
but answer changes, ma'am, when I do
How
it
will the answer
in
change?
my way.
This is the same thing I am also doing, no?
Ma'am, I have another 2 questions.
You have another?
Yes. First question is, can we use total probability theorem for independent and dependent both cases?
See, if what happens if, let's say here in L and M are independent. In that case, probability of L given M is just probability of L. Because we are saying L is not independent. I mean, a person being left-handed is not at all depending on male or female, right? If we are saying they're all independent, then you don't have to do this, no? I mean, it is not, I mean, probability of L given M is just probability of L in that case.
No, ma'am. No, not this question. I am generally asked.
Yeah, I mean, that's what I'm saying. Just take this as an example. If you're saying it's independent, then, I mean, you
Can
don't
we
even
find
have to do
total
all this.
probability? Can we find total probability if it is a independent case?
Okay, let's say in this question, what question do you want? What answer do you want to know?
I want that if case is independent.
No, just tell me the case. I mean, what case?
Case is like picking balls.
Taking?
Picking balls
Taking?
from bag.
No,
From bag.
I'm saying, you tell me in this example.
No.
Not in this example.
Yes.
You want in the ball and the bags.
No, ma'am. Let's start. What is the probability of M intersection and intersection P
M intersection
and intersection P
P.
if M and P are independent?
You're saying only M and P are independent.
No, all M and
All are independent.
yes.
Then it is just probability of M times probability of N
Yes.
times probability of P.
Yes. If it is dependent,
Then you can't write this. Then it shouldn't be equal. Then in that case, you will have probability of M.
probability of MI.
MI? How did you get M?
No. You can write.
So probability of M given N times probability of M given N intersection P.
No, ma'am, that's wrong.
Sorry.
No.
Sorry.
Yes. It is opposite.
Yeah. So it will be probability of M times. Hold on. Yeah. Probability of M times probability of N.
NYM.
N?
E1M. E1M.
Yes.
Hold on, I must have written somewhere.
Ma'am, probability of P given M because M is happened na.
Yes.
Right. Here. So probability of E1 intersection E2 up to En is probability of E1 times probability of E2 given F1. Sorry.
Yes.
We can
At another question is if in this case on it is dependent case, we use Bayes theorem. Yes, ma'am.
I mean, why
When-
we're talking about independence and dependence there? I mean, see, the setting is from the setting itself, it is clear, no? I mean, the way we have set it up is like this. You can look at this figure. So we have the population.
This no, ma'am. Just this example, it is dependent because first we have male and female. It is depending on the probability of left-handed is dependent on male.
That is true.
Like
Yeah.
first.
Yeah.
That's why I am asking dependent and independent case. We use Bayes theorem in dependent case, but can we use Bayes theorem in independent case?
You try doing it, no? That's what I had told you. Like you take this example. Where did it go? Yeah. You take this example. If we are saying they are not independent, they are not dependent, then probability of this L given M, you will just study it as probability of L times probability of M.
Yes.
Yes.
Okay.
Ma'am.
Ma'am,
One thing, I know this is it is not an open session or the doubt solving session, but I have 2-3 doubts, only 2-3 questions. Like if you after this, like in the end, can you look at those questions if you like?
Yeah, sure. Just I have one more question. So this is done. One more question is left, and then we can take.
Yeah, sure.
The formula you have written for the PM condition L1.
Where? Which one?
Can you slide towards the right, ma'am? It's basically Bayes' theorem now.
With this one, yeah, this is Bayes' theorem only.
Yes, ma'am.
Bayes' theorem, yeah. Okay. All right. Hope this is clear to all of you. Does anyone still have doubt here? Okay, let's move further then. The question says, in a test where you have 3 sections and any student can pass the test if he passes either section 1 and 2 or section 1 and 3. So that is the criteria, and the probabilities that any student passes section 1 is P, any student passing section 2 is 1 by 4, and probability of student passing section 3 is 1 by 3. Okay, and we are saying all these 3 events are independent. Now you find the value of P if probability of passing the aptitude test is 1 by 3.
I think it's a real test.
It's a real test.
Yeah.
Okay. Yeah, just think about this question a little. So do you want more time? I see only 9 responses here.
Just give me, ma'am, some more time.
Ma'am, where to respond?
Where? What?
Where to respond? You said only 9
Peer deck.
responses.
Yeah, peer deck. You can see maybe 9 on my screen. You can see 9 responses.
No, but where can I respond? Like in the chat?
No. I will just reopen the screen. Hold on. Now you should be able to answer. Type your answer.
No, but where? Like in the chat or like in somewhere? Should I
No,
go to
peer
some
deck.
website?
Peer deck, right?
Peer deck.
Yeah. You go to joinpd.com. You click on, you type the code as you see on the top right hand corner of the screen, and then you should be able to type your answer.
No, I wrote the answer already. Is it already submitted?
Yeah, it is already submitted. Okay, let's see the answers now. Yeah. 7. All right. Okay. So here, the question that is asked is, you need to find the probability that a student passing the section 1, and that probability is given by P. And the probability that the person any student passes the aptitude test is 1/3, right? So you need to find, so you have to find the value of P. Let's walk through the solution. So, okay, let's go back here. So what is the how do you find the probability that a person passes the aptitude test? So it is given to you that any student will pass the aptitude test if he passes in either section 1 and 2. So either 1 and 2, so 1 union 2 basically, or 1 union 3, right?
Intersection, no?
Intersection, ma'am.
Sorry, intersection, yeah. Intersection, 1 intersection 2 or 1 intersection 3, right? So this is the probability that a student passes the aptitude test. So this is what we have done here. So we have written this case when student passes the aptitude. So that is section 1 pass and section 2 pass, or section 1 pass and section 3 pass. Basically, in short, we can write it as pass 1 and pass 2, or pass 1 and pass 3. So this is the case when we say someone passes the test. Now we need to find the probability that a student passes a section 1, right? So we have to use all this information and we can come at the conclusion. So what is the probability of a person passes the test? So let's see the events. Events for pass 1 and pass. There are 2 events, pass 1 and pass 2, or pass 1 and pass 3. So the first event is pass 1 and pass 2. Second event is pass 1 and pass 3. So you know A union B, if you denote the pass 1 and pass 2 as event A and the pass 1 and pass 3 as event B, then probability of A or B is what? That would be probability of A plus probability of B minus probability of A intersection B, right? This is what we are going to do. So probability of pass 1 and pass 2 plus probability of pass 1 and pass 3 minus probability of pass 1 and pass 2 and pass 1 and pass 3, right? So see, these probabilities are already given to you. The probability of someone passing section 1 and section 2. So it is given that, okay, that is not given, and it is given to you that these events are independent. This pass 1, pass 2 and pass 3 are independent. So you can find probability of pass 1 and pass 2. So that would be what? Probability of pass 1 times probability of pass 2. So that is nothing but P times 1 by 4, because probability of a student passing section 1 is P and probability of student passing section 2 is 1 by 4. So their intersection, the probability of intersection would be P by 4. Similarly, probability that a student passes section 1 and a student passes section 3 would be P by 3. So that is done. But now you need to find this probability that you are subtracting. And what is this event? This event is probability of A and B, right? And event A is probability of pass 1 and pass 2. And B is pass 1 and pass 3. So if you take the intersection of all this, you are just getting probability of pass 1 times probability of pass 2 times probability of pass 3, right? Because all these events are independent. So that is nothing but P times 1 by 4 times 1 by 3. That will come out as 1 by P by 12. Right? Now you just solve for P by 4, that is probability that the student passes section 1 and section 2, and plus P by 3, which is nothing but probability that the student passes section 1 and section 3, minus probability of student passing section 1 and student passing section 2 and student passing section 3, which is P by 12. So that gives you P by 2. And now, since it is given that it is given in the question that student passing the aptitude test is 1/3. So our P by 2 is nothing but 1/3. So that will give you 0.67. Is it clear to all?
Ma'am, I
Yes.
have
Ma'am, why can't we take it as just simply, I mean, why do we need to subtract that intersection part? Can't we, I mean, when we say and, we multiply, when we say or, we add, right? And why we
Right.
need to subtract this this portion is a bit confusing. When to subtract, when not to subtract.
Because
Yeah, ma'am, I did the same mistake. I didn't subtracted it.
yeah.
and one more thing, ma'am.
Mhm.
These events are independent events. So why we have not multiplied with P multiplied by 1/4 plus P multiplied by 1/3?
We have done that, no? We have done that. But the question that was asked, look at the question carefully. See, the question asked, find the value of P if probability of passing the aptitude test is 1/3. So it is given to you that the probability that a student passes the aptitude test is 1/3. Okay. So the probability is already given to you, but now there is some variable term which is unknown to us, some unknown term which is P. That is what you have to find, and we know that any student passes the aptitude test if they satisfies these two criteria. The first is either the student passes section 1 and section 2, or the student passes section 1 and section 3. Maybe I will also write down this. Just give a minute.
Hello, ma'am.
Yes.
Ma'am, is this slide available for future reference?
What?
Ma'am, is this slide will be available for future?
This session itself is being recorded. You can go and refer
Yes.
to that.
The peer deck slides, yes, those will be available to you. So
Ma'am, I'm asking about PDF.
this PDF, I think even if I give you it, since I'm using in black and white, so let's see. I don't think it will work. If I switch background, I think you won't be able to see it properly.
Ma'am, if possible, then upload PDF.
But will you be able to see this yellow color?
It is visible.
Okay,
If possible, then please.
see, I will not be able to change the colors now, right? So,
Ma'am, if yellow color is visible, don't worry, it will be okay for me.
okay, I can upload it if.
Okay, ma'am, then upload it, please.
Okay. I will
Okay,
make
thank you.
sure that I write in the white background. See, the question was probability that a student passes the aptitude test is 1/3. Right? And when does a student pass the aptitude test? This is when either the student passes section 1 and section 3.
Section 1 and 2. Yeah.
Yeah. Yeah, I will write 2. Section 1 and 2, or
section 1 and 3.
1 and 3. Right? This is 1/3.
Correct.
Okay. Now, probability that now it is given to you. Okay. Now treat this as, let's say, this is event A and this is event B. Okay. So probability of, A or is treated as union. So A union B is probability of A plus probability of B minus probability of A intersection B.
Ma'am, can I interrupt here for a second? So, yeah, why we need to subtract? See, when we say P intersection A intersection B, we are saying probability of A into probability of B.
Correct.
Right? And then when we say probability of A union B, why can't we say probability of A plus probability of B? Why we need to subtract this?
Because you see from the Venn diagram.
Yeah. No, Venn diagram, I understand that, ma'am.
Why you're saying why here? Because
yeah, it's like, is it something to do with dependent, independent, or is it something to do with the any other case?
See,
When to do this?
whenever you find the union, you always subtract from intersection, right? Unless and until A and B are disjoint, right?
Okay.
Unless and until A and B are disjoint, you will always subtract it from A intersection B. But in this case, A and B are not disjoint, right? I mean, it is nowhere given to us. This information is not given to us that the event A and B are disjoint.
Yeah, A and actually, ma'am, whether they are given or not, actually A and B are not disjoint because both A and B have section 1. So,
yes.
So they are actually in a way not disjoint.
Yeah.
Because
section
1 is common between both.
Right. So if they are not disjoint, you cannot make this A probability of A intersection B to be 0. Right. So you need to subtract.
Okay.
Right.
Okay.
So now what is probability of A? Probability of A means probability that student passes section 1 and section 2 plus probability that a student passes section 1 and section 3 minus probability of A intersection B, which is probability that student passes section 1 and 2 and 1 and 3, right? And what is given to us is even this 1, 2 and 3, they are independent. If they are independent, it means I can write probability of 1 intersection 2 as probability of 1 times probability of 2, right? I can write probability of A and 3, 1 and 3 as probability of 1 intersection probability of 3. Okay. Minus, this is nothing but, so this is 1 and 2 and 1 and 3. So this is 1 and 2 and 3, basically. Right. So now all these probabilities were given to you. This was P. This was 1 by 4, I guess. And this was 1 by 3, right? So just
ma'am, we are subtracting the case when the student passes in all the 3 sections.
Right. So this will give you P by 4 plus P by 3 minus P12. So this turns out to be 12, 4, 3P minus 4, 3P plus 4P minus P. Right. So this is 7 minus 6, 6P by 12, which is P by 2. And it is given to us that probability student passes, this is P by 2.
Yeah.
This should be P equal 2 by 3, which is 0.67.
Yeah, ma'am, actually just, okay. So, if ma'am, so in A union B is not always A plus B, but A plus B minus A intersection B. That is when, when the events are not disjoint.
Correct.
Okay. And similarly, A intersection B is not always A into B.
Correct.
Unless the events are completely
Independent.
independent.
Yeah,
Correct?
right.
Correct. This is the whole summary actually where I'm missing and getting confused a little bit.
Okay.
So, ma'am, generally, when there's a question.
Ma'am, sorry, sir. Let me just complete my question. So, if the events are not disjoint, then P of A union B equal to P of A plus B minus P of A intersection B.
Right.
Likewise, if the events are not independent, then P of A intersection B is equals to P of A into P of B. And what, ma'am?
Given A. So if A and B are not independent, if A and B are not independent, then probability of A intersection B
is equals to
is probability of A times probability of B given A.
Okay, instead of PB, instead of probability of B,
You
it
can
is
think of
probability
it
of B
as
given A.
joint probability, right?
Oh,
Joint equal marginal times conditional.
okay. Yeah, I think this is making somewhat clearer now. Yeah, thank you.
Yeah. Somebody else had doubt, no? Can you go ahead?
Yeah, ma'am. Ma'am, so simply, like here it was odd. So I was applying that addition rule, like of addition. So, but here it's we have to subtract it because independent events are given.
No. We are not subtracting from A intersection B because events are independent. No, that information we are using to find these probabilities. I mean, what was independent was probability of the event 1. Event 1, 2, and 3 were independent, and event 1 was defined as probability that a student passes section 1. Event 2 is probability that a student passes section 2, and event 3 as probability that student passes section 3. That was defined as independent. But why we subtracted, like this is the addition rule, right? This is the addition rule that you have seen before. So probability of A union B is always probability of A plus probability of B minus probability of A intersection B. You won't have this A intersection B term only when the events A and B are disjoint, right? But in this case, you can see that this event A and B are not disjoint. This information is not given to you in the question that the event A and B are disjoint. So you need to subtract A intersection B from A and A plus B.
Ma'am, actually, as I mentioned, just a small correction, ma'am, so that it is clear to that other girl who is asking. So this is my understanding. Correct me if I'm wrong, ma'am. So section 1 and section 2 and section 3 are completely independent.
Correct.
And also they are disjoint, if I'm right.
Yeah, right.
Whereas A and B are not disjoint because both A and B contains section 1 which is common.
Correct.
And hence we will have something called intersection B, A intersection B, which needs to be subtracted.
Yes.
Is this making sense, Shubhi?
Yeah, I got it now.
Yeah, I mean, because this is the same link I was also missing earlier, but from this session I was able to, overcome that, and hopefully I'm able to make it now.
Yeah,
So I'll try to make it clear to the other lady.
So you can also see it from the figure, no? So
Yeah.
You have, let's say,
Ma'am, and that A intersection B that you have written, probability of A into probability of B, condition A, it's for dependent events, now.
Yeah. So this is how it is, right? Let's say this is my event 1. This is my event 2. This is my event 3. So 1 intersection, 1 and 2. So 1 and 2 is this. 1 and 3 is this. Right? And you have to take the union of these two. Right? You see, they're not disjoint. You can see, right, in the figure.
Ma'am,
Yes.
ma'am, I actually solved this question by two methods. I wanted to know which one was correct. So one I did by the method you did. The formula, the usage of that formula, P A union B.
No, how did you find this solution?
No, the exact same thing you did. Like if like P1, I did two
You
methods.
did the same thing, right?
Yeah, I did that one also, but I initially did one thing which was very short and quick. That's why I was able to do it one way or one time. So what I did is, I don't know why I didn't get answer by this first method. I usually get it in these type of questions. So they said that in S1 or in S1 S2 or S1 S3, like he should pass in these two. So or condition, which means addition. So yeah, the condition this or that, like these conditions
Correct.
should be.
Correct.
So what I did is just probability of pass if let's say if he passes in S1 S2, which is the first case. So the passing in first section would be P given, which is given, into passing in second section, which is 1/4,
Yeah.
into not passing in third section, which is 2/3.
Okay.
And then on addition, and then I did plus. Then in the according to the second condition, he should not pass, that student should not pass in second test if he is passing in first and third. So what I did is P into 3/4, because that probability of not passing in second test,
3/4, yeah.
into passing in third test, which is 1/3. So I did this condition, and I put it equal to 1/3. Because this is a probability of passing the test. So these are the overall probability that what I explained to you, and the overall probability which is given of passing the test is passing the round is 1/3. I didn't get the answer this time with this method. I usually get it like in these type of questions.
Okay, what you are saying is okay, let me just write it.
Ma'am, are the questions
Ma'am,
over?
ma'am, can you summarize what he is trying to say, ma'am?
Yeah, questions are over. That was all the question I had in the slides. So, okay, what he is trying to say is we have to find probability that student passes the test.
Correct.
And he's saying this is probability that student passes section 1, S1.
Correct.
Intersection S2 complement, intersection S3, plus probability that student passes in section 1, intersection section 2, intersection S3 complement. This is what you're saying, no?
Yes.
Okay, so okay.
What is the rationale, ma'am? Why should it work like that? I didn't understand.
It's a common method which is like if you solve it like these questions very frequently, you will get like this is a concept like this is also a quick method in order to get answers to questions like these. So
one intersection.
One or two.
S3.
The pass in section 1 and 2 is same as pass in section 1 and 2 and not passing section 3. Maybe, okay. See, I think, okay. It is possible, no, that it is possible that student passes all the 3 sections. Then in that case also, the student passes the test, right?
So we will add that also, right?
Yes.
Yeah, that's the weird thing. I noticed. I also like if you, when you were discussing the answer.
I mean,
I
not add. Okay. If you
yeah, I
add,
added. If you also do it, if you can do it in 1 minute. If you do it, then you will also notice. If you add it, then you will get that 2 by 3 answer. I was also confused as like, why should we have to consider this condition? Like if he passes in all 3, when it is clearly mentioned that student
No.
passes in either S1, S2 or in S2,
question
S3.
only says, question says that you can pass the aptitude test if either you passes section 1 and 2 or section 1 and 3. But like that is the minimum requirement, right? I mean,
So, do we automatically consider that he should not pass all 3 subjects? Like
No,
when
no,
he will not pass? Like
no,
it is
if
very
you
absurd to think like that, but is it, we'll consider it like that or not?
No, friend. I think the point here is if someone passes all 3 sections, it is not that they failed. I mean, they didn't meet the criteria. But
Yeah, it's
point
absurd
is,
to, it's very
but the
absurd to
point
think
is,
like that, of course.
but the point is, he will be double counted. He should not be double counted because he passed section 1 and section 2, and also section 1 and section 3. He should not be double counted. I think that is the point.
yeah, in that case, we are counting it twice. Yeah, right.
Yeah, so what should we modify in this formula in order to get our answer?
That I'm sorry, because I don't even know this formula first.
No, I'm asking ma'am
The
about this.
formula, okay. I have not seen this formula though, but okay. So if you use this, see here, what you are doing is you are saying that the student passes in section 1, so that would be P times not passing in section 2, that would be 3 by 4, and this would be 1 by 3, right? This was that, and plus you would have P times section 2 would be 1 by 4 and section 3 complement would be 2 by 3. Right?
Yes, ma'am.
Okay. So this gives you what? This gives you P by 4 plus P by 4 times 2 by 3, which is simply P by 6.
Yeah.
Ma'am, I think here we have to add S1 intersection S2 intersection S3 is to be added here.
Yeah, because that is missing here, no?
That is missing here actually.
Yeah, because we are not considering the case when the student passes all the 3 sections.
Yeah, so we have to add that one also.
Yeah, so you need to add S1 intersection S2
intersection S3.
So that will give you P by 12.
P by 12.
So what will you get from here?
Yeah, then if you do it, then I think you would get the right answer, 2 by 3.
So 3 plus 2.
Plus
Okay.
1, 6p.
6p.
Yeah, 1 by 2p.
Matching.
P by 2.
So missing link is S1 intersection S2 intersection.
Yeah, so it's a good like the concept which is being cleared here is if it is not even mentioned in the question that the only conditions which were mentioned were like if he passes, that person passes in S1 S2 or S2 S1 S3. But we would still consider the case in which he passes in all the 3 sections.
Yeah, because like you think of some exam. Let's say you are only writing some exam. Like it's not like if you pass only section 1 and 2, you are pass. Even if you pass section 1, 2, and 3 all, still you are passed, right?
Yeah, of course, of course.
Yeah. So
It's
that is why you need to consider that case.
it's like being overqualified. If you have succeeded, overqualified the condition which was given.
Yes. So we cannot ignore that. So that's why we have to add that event.
Okay. Yeah, ma'am. Then it's okay.
Yeah. Okay. So okay. Tehseen, you have any question? You have raised your hand.
Yes, ma'am. I have a question regarding extra activity. I have a doubt regarding extra activity in statistics.
Okay. Tell me.
Ma'am, we have to give permissions to the link to IIT Madras.
You have to like when you go to your whatever extra activity you have submitted.
Yes.
So you have to give access to anyone in the domain study.iitm.ac.in.
But ma'am, we don't have received student email ID yet. We have qualified recently in September term. There
But
comes
you are a foundation student, right?
Yes, sir. Yes, ma'am. I am a foundation student, but we don't receive student email ID yet.
Oh, even you have not received.
No,
Yes.
nobody has received, ma'am. That is the problem.
Yes, ma'am. Nobody has received student
Nobody
email
has
ID.
received.
Only,
That's why we posted so many questions.
only two options are coming: public and private, ma'am. There is not any option coming IIT Madras. Give permissions to IIT Madras.
Okay, because you will get that permission if you are doing it from your student ID.
Ma'am, we don't have received student email ID yet. We are September qualifiers.
Okay. Okay, then
Last date, the last date of extra activity is 24. But we have to give permissions to IIT Madras. Only there comes only two options: public and private. We have to give either public or private.
I think you should give. I think if you give to public, and all IIT Madras people will be able to watch in the absence.
But you will have to only give view access. Don't give any editor access. You give only view access.
What, ma'am?
You have to give only view access. Don't give the editor or the commenter access. Give only the view access.
Yes, ma'am. We have view access, but only there are two options coming: public and private.
So
you
will have to do public, but view access, only view access.
There is not any option coming that view access, give view
Yeah,
access on.
because as you're saying, you have not received the student email ID, so it will not come as that option. But I was not aware that even the foundation students do not have the student ID.
Yes, in morning I called the support team. They told me that tell your instructor, he or she will say you what to do.
So okay, let me check. Maybe by tomorrow morning. So you work on your assignment, you work on your extra activity. By tomorrow morning, we'll let you know. Okay, because we'll let you know by when can you receive.
Lot of students are facing this problem, ma'am.
Yeah. Yes, I completely understand that.
Please tell us.
Can you go to the questions in the chat box, ma'am?
Yeah, let me go.
Ma'am?
From the beginning.
Excuse me, ma'am.
Yes.
Ma'am, I asked you about the questions which I had to discuss with you earlier in the session.
Yes.
So
I am going to the chat. Just give me a minute.
I will provide the link.
A lot of questions there. Okay. The first one is. Okay, the first question is, suppose we roll a pair of fair dice so that each of the 36 possible outcome is equally likely. A denote the event that the first die lands on 5, B denote the event that the sum of the outcomes is 10, and C be the event that the sum of the outcome is 7. Then choose the correct option.
Okay. Maybe you can open that question, ma'am, by clicking there on the chat box.
Yeah, I can. I'll have to share the screen.
Yeah.
Okay.
Ma'am, the question which we did, the last question,
Hmm.
It was the way they framed that question was a bit confusing. They like if they stated that question like if the person will get selected if and only he passes at least 2 sections. Then
No,
that case would have been considered that S1, S2, S1, S3, and then that.
no, friend.
Then
If
in
they
that
say-
case, 2 and 3.
Correct.
Yeah, but yeah, they should have mentioned that only like somehow like they should have framed that the question in which the way I'm telling is like
No, requirement is that section 1 is mandatory to pass. And
Yeah, of
out of
course.
section 2 and 3, if what they pass either of them, then
Yeah.
the candidate is considered as pass. I think that
Yeah.
is the requirement.
Yeah,
Yes,
of course.
yes.
So we would, ma'am, then in the similar type of question, we would use our common sense and then we would also make our own condition, which is not even mentioned in the question. We can do that, right?
Hmm.
In all such questions.
No. Can you repeat the last sentence?
Ma'am, I'm saying that we did this, the third case, we did by our common sense. Like we did that, what we considered that if he
Yeah.
passes in all 3 sections, then of course he would be passed in overall.
Correct. Yeah.
So, but even if this case were not mentioned in the question, the only 2 conditions were mentioned were S1, S2 or S1, S3.
Hmm.
But we still did that case that he passes in all 3 tests, S1, S2, S3.
Hmm.
So all in these such questions, we can like apply our common sense and get the other condition.
Yeah.
Like, can we
Right.
do that? The common sense conditions, which like.
Yeah, I mean, it was, if you look at the question, it is quite clear that, I mean, that was obvious that to
Yeah.
pass, you need even all the 3 sections to be done.
Yeah, like they specifically mentioned that S1, S2, S1, S3. So like firstly, when I did, I didn't consider the case when that person passes in all the 3 sections. So like because they specifically mentioned the 2 conditions.
No, friend, what you're actually missing is, ma'am, sorry,
Yeah.
sorry.
No issues. You can go ahead.
Yeah, friend, what you're missing is there is no confusion there in the question. Actually, if you pass section 1 and 2 or section 1 and 3, the student is considered passed. Now,
Yeah.
what you're saying is if somebody passes all 3, doesn't mean that he has failed because he passed section 1 and 2, so he is considered passed. And because he also passed section 1 and 3, he is considered passed. Now
so that's what I'm saying.
Now that you should not double count him twice, you need to subtract that whatever duplicate case that you're considering. That's all. Otherwise, there is no question about the definition of pass or fail, right?
Yeah, no, but what we did by my method, we didn't subtract anything, first of all. And then what we did is we actually added the case in which the person passes in all the 3 sections, which was not mentioned in the question anywhere. The only 2 conditions which were mentioned were like S1, S2 or S1, S3. So we did it by our common sense. We added the third case in which the person passes in all 3 sections by our common sense. So that's what I'm saying, that can we do this in all such type of questions, or like is it like or not, like simply or just not, or in this question only we can do that, the common sense condition framing which we did.
I mean, depends on the question. I would say, I think in most of the cases, like you saw the formula for A union B addition rule also, right? This is what the
Yeah.
addition says. So if something is common, you need to like subtract from there.
Yeah.
So, but when you were doing it, you were not even considering the common part even once,
Yeah, I didn't.
right? So that is why we had to add it once. But when we are doing it like using addition rule, we were counting it twice, so we had to subtract it once.
Yeah.
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 So, like I think in all the cases, in all the questions, this would always be the case. Yes, you will have to look at the question carefully, maybe.
Yeah, so we can form
understand,
another condition by using common sense, like.
Yeah, the context of whatever the question has been asked, you'll have to maybe look at it very carefully and like what exactly you have to find there.
Yeah, because as we knew that in this condition, of course, if he passes in all three, he would not fail. Of course, like it's a like such an absurd way to think it like that. If he would fail if he passes all the three sections. So we did it by our common sense that if he passes in all three, he would automatically considered as pass, right? So we can apply these common sense. Okay, then, like if that's the case, you're trying to say, right?
Yeah.
Okay.
Okay. Okay, let's look at this question. All right. So here we have to check whether event A and B are independent or A and C are independent or not. So what is the doubt here? I think this is a very straightforward question.
Ma'am,
Tell me.
even that some of the outcomes of the
Event A is the event that first tile lands on 5. So the outcomes would be 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. Okay. So probability of A is 6 by 36, which is 1 by 6. Now B is the event that the sum of the outcomes of rolling the pair of dice is 10. Then in that case, the possible outcomes could be, it will start from 4, 6, 5, 5, 6, 4. So you have 3 out of 36. So 3 by 36, which is 1 by 12. Now even C, sum of the outcome is 7. So if sum of the outcome is 7, it means the outcome, the possible outcomes that you can have for this event is 1, 6, 2,
Ma'am.
5. Yeah. Tell me.
Ma'am, they are actually just, I think here the question is only, are they dependent or independent is the question, ma'am. The numbers are not asked at all here.
Correct.
So here the problem is actually, one second, ma'am. Let me show you. So the confusion is this. So what are the correct options, ma'am, in this in the given list?
So you're saying B and D are correct.
Yeah, that's what I was thinking, because A and B are dependent because we are talking about the getting the total value of 10 given A has lands on 5.
Correct.
Because the first die has already landed on 5, and between A and B we want the total of 10. B is dependent on A, right, ma'am? Is that correct or not?
B is dependent on A.
See, in a normal scenario, they're independent, ma'am. There is no dependency between A and B.
Okay.
But here they are saying that A lands on 5 and B be the event that the sum of the outcomes of rolling the pair of dice is 10.
Correct.
That means in order to satisfy this condition, B has to also land on 5.
5, yeah.
Why? Because A has landed on 5. So that means B is dependent on A.
Correct.
Ma'am, that's the rationale behind selecting the second option, event A and event B are dependent.
Okay.
Yeah, it's one of the events you said in which
Right,
5 would be there. It is one of the events. 5, 5, that would be the element. And there would
Right.
also be 4, 6 and 6, 4 in B.
No. Because A has already landed on 4, 5 and other things will go away.
No. B is another event, which is B be the event that sum of outcome is of rolling pair is 10. So there would be 3 elements, 6, 4, 5,
6,
5 and
4,
4, 6.
5, 5 and 4, 6. Yes.
Yeah,
These
but
would be the
because
element.
A has already landed on 5, B can take only value of 5.
No, it's not like that. It's not. That's why the conditional probability formula is there. Intersection part, the first part, A intersection B. You create all event A and B independently, and then you take the common between those two, and then you do probability of that. That's why the intersection part is there in the formula.
No, correct. So is the second option right or wrong? I mean, see,
I mean, the easiest way you can do this question is just create the event, like the set of all the elements which would be in that event. And then you can just find the probability of A and probability of B. And then you can just do probability of A into B, which should be equal to like probability of A intersection B. So it would be, if they are equal, then they are like, what was the case? If they are equal, then they are
independent.
Then they are independent. And if they are not equal, they are not independent. The easiest way to do is by this method.
Yeah,
So-
ma'am.
Yeah. So like whenever you have to check, whenever you have to check two events are independent, so you just need to check whether probability of their intersection is same as probability of the individual, the probability of product of the individual events. Product of probability of A and B basically. So what you were also saying is kind of right, because whenever you have to check for like when we say something is independent, it means occurrence of one event should not be affecting the occurrence of the other event, right?
Correct.
In any way. But whatever like you could give the reason you give, that also seems to be right.
So here, what is the correct answer, ma'am?
Correct answer, A and B are dependent, right?
A
Because
or B independent. Okay. Then what about A and C?
A and C, some of the outcomes you're saying, okay, C is, some of the outcomes is 7. So probability of C is what? For that case, you have the outcomes 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. 6 divided by 36. Right? And what is probability of A intersection C? That would be only 1 by 36. So probability of A, which was probability of A, which is 1 by 6, probability of C, which is 1 by 6, and probability of A intersection C is product of A and C, right? So A and C are independent. And A and B are dependent. Is that the right answer?
Yeah, actually, that was the right answer, ma'am. Correct. But, ma'am, can you just do it here? I mean, I couldn't follow you when you explained. Can you just explain here on the board?
Right?
On the board.
Can I write it here? Wait.
Ma'am, why is not the math session being recorded?
Math session is not being recorded. I'm not sure. It should be live streamed, no?
Yeah, it should be. That's why the YouTube link is also provided. I thought that I would watch it later, but I'm seeing that there's
These
no link.
recordings are helpful, ma'am. Wherever we are still not clear for whatever reason, we can just go back and repeat that probably if required.
Yeah, like it's very helpful. I watch it at 2x and then go through all the questions. So if I am having doubt in one, I will just
Currently,
stop
you're
and
saying 8 o'clock math session is going on.
yeah, right now it's 8
Is
to
it
10.
TA session or instructor-led
No,
session?
it's open. It's all with us, I guess. The exact same session as yours.
Okay. Maybe I will inform.
Yeah, it's all with us.
Okay. Just give me a minute. Okay. I have informed, maybe they should. So whoever the instructor is, you can just inform them in the session.
Hello.
Ma'am?
Yes.
Excuse me, ma'am, I have a little doubt.
Hold
like,
on. Let's finish
hello.
this. Let's finish this first. Okay. Wait.
Ma'am?
Yeah, let me.
Yeah, you complete this. I will just inform them when I join the math session.
Okay.
I am just leaving this right now. I said we'll discuss the question, right? I'm just leaving for 1 minute. I will inform them, then I will come back to this session.
Okay, sure. So when do we say? We say events A and B are independent if probability of A intersection B equal probability of A times probability of B. This is actually if and only if.
Correct. Yeah.
Now, event A is, what are the outcomes? The event A says the first die lands on 5, right? So that would be 5,1, 5,2, 5,3, 5,4, 5,5, 5,6, right? Event B would be, it says sum of the die is 10. So that can be 4,6, 5,5, and 6,4, right? And even says sum is 7. So that is 1,6, 2,5, 3,4, 4,3, 5,2, 6,1, right? Fine.
Okay, ma'am.
Now, what is A intersection B? This is just 5,5. What is A intersection C? This is 5,2, comma 5, only 5,2, right?
Okay.
And you have to check for the independence of A and B and A and C.
Correct.
So now what is probability of A? It is 6 divided by 36. What is probability of B? It is 3 divided by 36. Probability of C, it is 6 divided by 36. Okay. Now, what is probability of A intersection B? It is 1 divided by 36. Probability of A intersection C is 1 divided by 36.
1 by 6, ma'am.
Why 1 by 6? Why 1 by 6?
Wait. Probability of A intersection C is.
This
Okay, yeah. 1 by 36, ma'am. Yeah, sorry. Because only one event possible.
Right. Now, can you check if what is probability of A times probability of B? So this is not equal to probability of A
Okay.
times probability of B, right? And this is equal to probability of A times probability of B. Sorry, C. Yeah. So from here, I will say A and B are dependent. A and B are dependent.
Okay.
And A and C are independent.
Okay.
Yeah.
Yeah, okay, ma'am. Thanks for taking time, ma'am.
Yeah.
Ma'am?
Okay.
Ma'am, can we discuss now?
Yes, we can.
Ma'am, I have provided the link.
Okay.
Wait,
Ma'am,
I'll go on.
actually, I have just very little doubt.
Oh, no, not this one. Sorry. Wait.
Ma'am, can you go through the chart, ma'am, one by one, please?
Chat. Yeah, I'm going to chat only. Hold on.
There's some Pratham Balla link, like it's written something like Pratham Balla, if you can find.
Pratham Balla, okay. There is one more question. Imran, if are you in the session? No, okay. I will leave that question then. Then you have one more question from Prashant.
Well, I just send that link.
Okay. Sure.
Yeah, my second question is relatively, I think, easy to answer, ma'am, for you after discussion, but still I have the doubt.
Okay, just hold on. Let me. Okay, Pratham Balla. Okay. What about this link?
Ma'am, if you scroll down to quiz 2 section.
Okay.
And then scroll a bit down to that the last January attempt, 24 Jan 2021.
Quiz 2 section. Where did it go?
Set 1, set 2, which are there.
Statistics for data science. I can only see quiz 1. Wait. Is it on the top?
No, scroll down.
Oh, you can see my screen?
Just a moment. No, ma'am.
No, you cannot. Okay, let me share my screen. I don't know which.
Yes, ma'am. Now it's shared. Oh, no, wait, no.
Ma'am, what is the question being discussed, ma'am?
Yeah, I'm just showing. Hold on. Yeah, okay. Tell me, where is it? I couldn't find out.
Ma'am, scroll down.
Okay.
Ma'am, like after the or much more scroll, like if you scroll down also. That's all you can get. Okay, wait.
I don't see any quiz 1, quiz 2.
Yeah. Wait.
Excuse me, ma'am.
Yes, tell me.
Ma'am, I have a verbal doubt. Please clarify it.
Yeah.
Like, if we write year like 2021 to 22 or 22 to 23, it would be nominal data or interval data or ordinal. Which category would it lie?
What can you repeat your question?
Ma'am, if there is a year is written like 2021 to 22 to 2022 to 23, it would be nominal, ordinal, or interval scale.
Okay. You're saying you are given the duration as 2021 to 2022, then 2022 to 2023. And okay. So nominal is not possible for sure.
Yeah, it would be ordinal, but in ordinal, as we can perform mathematical operation on it or not. Like, I'm confused.
Depends. See,
Yeah,
this
we can do it.
questions, right? It depends on the context like what question you are asking?
Actually, I'm creating that extra activity part. So in the data set, there is column of 2 years, like in which year what event happened. 2021 to 22 what happened, and 22 to 23 what happened. Like that there is column. So that column I have to describe about it. So it would be categorical, but in categorical it would be nominal or like ordinal or interval. I'm confused little bit while
You are
describing.
saying the year will be categorical.
Ma'am, it would be nominal or categorical.
Numerical or categorical, you meant to say.
And when if it would be not, if like it would not be in the ratio scale for sure, I'm got, but it would be, it could be interval or it could be ordinal. I'm confused in that.
Okay. For the interval scale, you need the interval to be of the same difference, right?
Yes, ma'am.
Ma'am, isn't it like there are two variables, categorical and numerical? If he is saying that the year comes in categorical variable, only two operations, like only ordinal or nominal, it can be measured in only ordinal or in nominal.
Yeah,
And the
but
other,
it is not given like it is categorical or numerical.
so you
We have
guessed
to
it.
define.
You guessed it categorical, right?
No, actually, I'm saying if it would be categorical, then it goes to ordinal data, and if it would be nominal numerical, then it would be in interval scale. But
okay,
yeah, so what it would be like for an interval scale, we should have equal size of interval, and addition and subtraction should be valid on it. So
Right.
is it in interval?
I would say it should be interval scale.
you can subtract to get the difference between 2 years. So that is there. You can apply maths.
Yeah.
And it's also like it also has units like year to year to like no it's not the unit. No, does it have unit? Like,
for ratio.
I mean, like when we measure age, its unit is year. So is it the same for like year 2021 or like 2020?
I think it should come into interval only, because you are able to like do the
Mathematical operations.
mathematical operations on it, no?
Yeah, I think also. So numerical and interval. What's the correct answer then?
No, actually there is no answer. I have to define it, and I've confused it so much that I'm not able to understand it. Is it ordinal or is it interval?
I mean, order also matters here, but it's not just. No, wait. Ordinal. You're saying ordinal.
It may be good idea to shoot the details to the ma'am and let her respond. I think that's better way probably, because if there is a question, either you can post it here so that it is very clear. Otherwise, you can just probably shoot a mail to ma'am and let her look into the details and respond. Maybe that's a better way.
So if you
So
can maybe what is the data set, it is important to see that also.
In data set, in that column, half of the data set considered to be 2020 to 21, and remaining half is from 2021 to 22.
Okay.
There is some entries which are in two categories, 2020 to 21 and 21 to 22. So I have to describe about that column. So that column would be ordinal or interval.
Okay. So what you're saying is
Then
you have the data set, and
yes,
in the data set, y- um, you the only thing is in that column you have duration 2021 to 2022 or
yes,
2022 to 2023.
yes, ma'am.
This is what is there in the data set, right?
Yeah.
Okay.
If it's written like that, that 2022 the dash 2023, then I
Yeah.
think it would be ordinal, no? Then like I thought it's only 2021 or 2022 is written. Then we can subtract and get the like difference between the years, but not written in that dash form 2022,
No,
2023.
like I have confused it because when we write interval, it is like 2021 to 22, which contains 1 year gap, and then 21 to 22, which also contains 1 year gap. So their interval is same.
Yeah, but it's written like 2021 dash 2022, right?
Yeah, but continuous data is written like that, na?
Yeah, it is.
While we have described continuous data in which we draw a histogram,
Okay, let's I'm not really sure. I think you should I think you should do it as interval, because years generally should be like, because it's year duration, no? And even the interval that you're talking about 2021 2022 and 2022 2023, the interval difference is also same, so that satisfies the property of your interval scale of measurement. So I think you should put it into interval.
yes, okay.
Yeah.
Okay, thank you.
Yeah.
Ma'am, I provided the
I
link
went to quiz 2. Yeah, what do you want me to check?
on the latest link.
Under quiz 2 what?
Okay, so in that quiz 2, you wait. Yeah. So in January, the Jan attempt, the first 24th Jan 2021.
Quiz 2 24 January 2021.
Yeah.
Okay. Set 1 or set 2?
I think yeah, any set 1 you can do.
Okay.
So page number 37.
Page number 37.
Like 38, I meant. So like scroll down a bit.
Okay. Okay,
So that triangle question you're seeing, the rectangle triangle diagram is there.
yes.
Yeah, that question and that other one in this same I have done. So like these two three questions I have.
You have doubt in the previous year questions?
Yeah.
So I think the TAs are already taking the previous year questions doubt.
No, I'm seeing the calendar. That's why I already told you that I know that it's not a doubt session or previous year session, but I'm seeing the calendar right now and I like there's no. What does office hour mean? Like what
Office
exactly is
hours,
there?
so the TAs are available, and they will be so if you have any doubts, they will you can ask them. That is why the office hour sessions are.
Okay, so like the doubts you can ask there.
Yes.
But
And
when I joined
take
it like 2-3 times. I found it like there was no teacher. Only me and other students were like waiting for the teacher and we're discussing by ourselves.
No, I mean there should be some TA over there.
Okay.
So please make use of those sessions also. Like I'm sure the previous year questions are being discussed, so you can you can ask there also.
Yeah, I will try, but I have 4 or 5 questions then, so I will only ask 2 here. Then if I because I don't know exactly because I joined
Already
2,
very
3.
late actually, so I don't think I'll be able to do it right now.
Only this one question, if you can like only this one. Okay, so
Um,
Because then there is no other session like after this TA session or like
Yeah,
doubt
there
clear.
are sessions. There will be like every week you have 3 to 4 sessions for TA.
Yeah.
Separate sessions, I'm saying. So maybe you can ask there.
Yeah,
Yeah.
like the next session is for session week 8 statistics one with the like the others are like office hours by TAs.
Yeah, office hours. So office hours are like for that only. Like if you have any other doubt apart from these 3 sessions that are conducted by us, then you can use those sessions to ask your doubts.
Okay.
Yeah. So those are separate sessions that happen almost like 3 to 4 days a week, apart from the 3 regular sessions. So make use of those sessions also.
Yeah, okay, I will try. I have already tried 2 times, but I didn't find any teacher there, so I was confused that what are these sessions for
No,
office
so
hours?
TAs are students only. They are students like you, but they have been selected. They have been shortlisted as TA. They went through the process. There's a TA. There is. I'm not sure if you're aware of the student TA start.
Yeah, I know. I've
Yeah.
talked
So
to
in the
some.
office hour session, student TAs will be there. So you can ask them the questions. Whatever extra do you have? Whatever is not possible to cover in these sessions.
So I think like if I'm not mistaken, you're also like student TA like also. You're also discussing.
No.
Okay, so you're okay. So yeah.
Ma'am,
Yeah.
would you be going back to the question list, ma'am? Sorry.
Yeah, just one last question, then we'll close it.
I think you already opened my question.
But am I sharing the screen?
No,
Ma'am, you're talking, ma'am, we were talking about my question, right?
I was talking about your question, but I don't. Am I sharing anything?
No, ma'am.
Okay. No, this is not the one.
No, next question, ma'am. Not this.
Yeah.
Yeah, this is also one question, ma'am. Yeah.
Okay, so this, I think one I had already proved in the last session that I took on Friday. So the first one, if events A and B are independent, then events A and B complement are also independent. So see, anything you have to prove, no? So if you have to prove events A and B complement are independent, you need to show that probability A intersection B complement is equal to probability of A times probability of B complement. So if you are able to show it using the information that probability of A intersection B equal probability of A times probability of B, then you are done.
Okay.
So you can try, so you can use this definition and try all these options. One I had already proved in the last class, and remaining you can try.
Okay.
Yeah. So you can go back to maybe the Friday session and look at the independence part. There, one has been already proved. So use that and try to prove the other one and see if they are independent or not.
Okay.
Yeah.
Ma'am, can we get back to my
One
question?
more. There is one more question, ma'am. A intersection B intersection C.
There's one more question.
That activity question, right?
Yeah, activity question 8.6.
Yeah, so the reason behind it is that it's like I already asked that question. The reason behind it is that it's incomplete statement, because if you look at the lecture, in the last few minutes, it is clearly mentioned that not only PA intersection B intersection C intersection should be equal to PA into PB into PC, or other intersections like PA intersection B should also be equal to PA into PB. PB intersection C should be also be equal to PB into PC, and PA intersection C should also be equal to PA into PC. All these 4 conditions should be satisfied, not the first one only. That is incorrect, incomplete statement which is given in that question. That's why it is false.
Oh,
Yeah.
oh, okay. So what you're trying to say is A intersection B intersection C, if it is equal to PA into PB into PC, doesn't mean that PA intersection B is equal to PA into PB.
No.
Yeah, it doesn't mean that it's not that, it's incomplete only.
Okay.
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 We'll close the
Thank
session for today. If you have any other
Ma'am,
doubts,
my 3-4 questions are, if you can do at least once, like I waited the
so
whole.
it's already very late, right? It's going to be 9:00 now.
Yeah, but just one question. If you look at it, or like give some
No,
hint, or
I'm
like
saying these sessions are already been scheduled, so please make use of those sessions, no?
Ma'am, doubt sessions.
The TA sessions, the TA session, open office hour session, please make use of it.
Ma'am, I have trust issues regarding. I joined 2 times. I didn't find any teacher. I'm telling the truth now only. Like I discussed with these fellow students only. That's why I'm asking you right now. I'm just having trust issues with that.
You shouldn't feel like that.
Ma'am, I joined 2 times and it was like around quiz 1. Even though I got like good mark, but still I had fear that these 2-3 questions which I had doubt in, if they come in exam, then like they would mess up my CGPA. Then so I was a little afraid. But then those questions didn't come up and I scored really good. But that's just luck. So that's why I have trust
Already
issues.
come will not come for sure. So
Yeah, that's true. But the same question, similar difficulty, similar time, and these all. If you do all the PYQs, like if all the 2021, 2022, then you get the idea how questions are going to come. I noticed that. That's why what I did in quiz 1.
So please, you solve the previous year question on your own, and if you have any doubt, like you can ask in the TA session, because they have been conducting the session. So
Okay.
yeah.
So the next session, you only take it. You will only take it the next session, the session 2, like for statistics 2.
For statistics too.
No, wait. Sorry, I think I didn't read it correctly. What was it? Yeah, session 2 week 8 stats 1. Sorry, session 2 week 8, which is on 24.
I don't know.
Achha, so it's not confirmed that you will take it or not.
Yeah.
Okay, so I can ask doubt there. I can ask there also, like these doubts.
No, that is why I'm saying, apart from like these sessions are for mostly for you to like the first session happens like we do the summary. Second session, whatever doubts you have from the lectures, we do it, and from the assignments we do it. And the third session we do solve with us. So the remaining all other doubts, if you have any, please utilize the TA sessions, because they have been conducting the sessions regularly. So use those sessions, and generally the previous year's session questions have been solved there. So please make use of it.
Okay, so these office hours session, right? Office hours.
Sessions, yes.
Okay, so I will use it then. And if I didn't find any teacher, then where should I complain about this? This would be the third time that I will.
There will be a teacher.
Okay, so.
Yeah. And you also have Discourse where you can put on the question.
Ma'am, that's what the problem is. I can't join Discourse, and can you just why I'm not able to join Discourse? Because I have the student ID, I have the official email ID, and the ITM ID which they gave me. I have everything, but why I'm not in a Discourse? Like what can I do to join a Discourse?
Please write it to support. Okay. We'll close the session now.
Okay.
Yeah. Okay.
Thanks, ma'am.